Let's take a look at the summary of this section. So for linear system right now, okay, so we did those many things. Firstly, we solve linear system by using Gaussian elimination method. So what's the elimination means? Means we reduce this into row echelon form, and then we do back substitution, right? Okay, and then we learned Gaussian-Jordan elimination. That means we reduce this into reduced row echelon form. And we did several examples. Sometimes there is unique solution. There is only one solution. And sometimes there are infinite solutions. Sometimes there are no solution. So when there is no solution for the augmented, if we get something like this row, right, there's no solution because this row is inconsistent. When do we have infinite solutions? When there is free variable. Okay, who is the free variable? That the unknown who has no leading one. Okay, and the unique solution just means regular. For example, if the reduced is like 1, 2, 3, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0. In this case, there is unique solution, right? And now let's take a look at another example. Example 5. Determine the solution set of ax equals 0. Okay, let's take a look at this one. That is ax equals 0 and a equals. Do you still remember what do we call this linear system? Homogeneous linear system. Right? Okay. So same thing, we can write down the augmented matrix. But the augmented matrix, we just add 0, 0 in the last row, the last column, because all the constants are 0. So let's write down this 0, 3, 7. Okay, it's pretty interesting because in the first column there's no leading one. That's okay, but we need all the ones start from the lower one has to be on the right side. So we want to change the second row in the first position. 2, 3, 0, 0, 3, 7, 0. And then we use that to make them into zeros, right? Okay, so the last row we need a leading one. So we change the last row, divide by 1, 4. So it's 0, 1, 91, 0, 0, 0, 1, 0. So this is this a row echelon form? No, actually we can make that into 0, right? Okay, this is the row echelon form. Now let's take a look at this matrix. Interesting. Who has leading 1? So this position is x1, x2, x3 position, right? So the leading ones are here. So x2, x3 has leading 1. Who has no leading 1? x1. So we set x1 equals t. Who has no leading 1? Yes, need to be free. And then x3 is easy to solve. x3 is 0. If we look at the second row, and the x2, look at the first row, x2 equals x3. Is that right? So it's also equals 0. So what's the solution? The solution set should be x1, x2, x3. T belongs to R, free variable. Okay, so this system has infinite solutions. Now let's have summary, the theorem. Consider a linear system, ax equals b. So we say for this linear system, and if R means the rank of A, and this R pound means the rank of augmented matrix. Then let's see the first conclusion. If R is less than R pound, that means what? It's kind of like this case. Okay, so this case, you can see augmented has more, the rank, the number of the augmented matrix is larger than A rank. So in this case, there's no solution. We say the system is inconsistent. Second, if R equals R pound, okay, that means the rank of A is same as rank of the augmented matrix, so the system is consistent. And when it's consistent, it may have unique solution, it may have infinite solutions, right? So case A, there is a unique solution if and only if R equals R pound equals N. Okay. B, there is infinite solution. That means there is a free variable if and only if there's 0 rows usually. So think about our matrix. If it has 0 rows, this is less than N. That means the rank of the augmented matrix is smaller than N. Okay. So this is the summary. In the future, you don't need to memorize, but when you see some matrix, you should tell when it is inconsistent, when it is consistent, and if it's consistent, for what kind of augmented matrix, it has infinite solution and it has unique solution. So you can tell that from the matrix, right? So for example, if I give you like 1 0 2 3 0, and the last one is 0 0 1 2 3 4 5 0. This is augmented matrix, and here I give you the row echelon form 0 0 1 2 4. For example, this one. Can you tell who are the free variables? This one definitely has infinite solutions, right? So infinite solution, and the right side is B. So you can see how many variables we have: x1, x2, x3, x4. So x1 can be solved, x3 can be solved. And so here x2 and x4 are free. So we make them to be the free variable s and t. So let's see then. Sorry, x3 is not free. Okay, so x3 equals what? Negative 2x4 plus 4, so which is negative 2t plus 4. So x1 equals negative 2. So here's s, here's t. Okay, negative 2x3, plug in, and minus 3t and the plus 0, right? Simplify. So should be 4t minus 8 minus 3t should be t minus 8. If we write down solution set, should be like this one. T minus 8, x1, x2 as negative 2t plus 4, and t. As t both are free variables. You know, in chapter 3, we are going to do more about this. Okay. it's like how to find the solution for a linear system, and this linear system has infinite solutions. We can stop here for this section.